Hello everyone, welcome back to another session by K21Academy. Today our expert trainer will be discussing about Kubernetes services and Nodeport. So let's get into the video.
Hello and welcome to this video. So we are introducing a new object called as Kubernetes Service. It's not that microservice service which we had discussed in case of Docker Compose and all. Service here is like a abstraction which is given on top of the pod. It's a logical entity, doesn't exist. It is just virtual thinking that we are giving a IP address. So we are just allocating one IP address and we are making that IP address as a static IP address. When we think about containers and pods, container is a Linux process which we had seen in the Docker level, that it is a Linux process and it has some resources associated with it. And you can kill a process, you can stop a process. So whenever a process gets starts up, it gets an IP address. But if I say that there is no process running and I just book a IP address, that means it's just a simple allocation of the IP address and nothing is going to restart, stop or get recreated that the IP address would lose and it will get a different IP address altogether. So pod is not having a static IP address because it is a process. We can kill a process, we can stop a process, we can delete a process, we can recreate a process, IP address changes that time. But when I talk about service, service will give us a static IP address because that is something we are going and just allocating and saying this has been allocated for this particular pod. How does the pod and the service matching happens? Obviously, label and selector are the ones using which the pod and service will match, and service will expose this pod to other applications if needed, and if needed to the outside world as well. So using the service IP address, other applications will communicate to this application. And when we are running multiple replicas of an application, so how do I depict that? Let me quickly pull my sketchboard and draw and show you. So here I have a pod. It doesn't matter where it is running and it has a container in it. So pod has an IP address which would be within the cluster's range, only accessible within the cluster, plus this is not static. That is the drawback to it. Now I am saying I am providing a wrapper on top of it called as service, and this service gets an IP address which is static IP, and this is also accessible across the cluster. So this will be in a different range, but this is a cluster IP range. Within the cluster, this service IP address is resolvable. And if I have pod 1, here this is pod 1, and I have another pod. Let me draw with a different color altogether. I have another pod called as pod 2 that has a container in it, and we have a covering so that we give a static IP address to this particular pod. So this is service for pod 2, and the first one is a dedicated service for pod 1. Now when the communication has to happen, it would happen from the pod's IP address container's port number, correct? It will go to service IP port number, and from there it will go to the other service, and here on this service pod 1's IP address, okay, with a port number combination packet would arrive, and when it's arrived here, it understands that okay, this is the pod to which I got to send, and container is listening on this particular port, and this is how the packet would reach from one location to the other. So now whenever the communication is happening, it's not with respect to pod IP talking to pod IP, right? Just think this is a front end and this is a back end service. I need to tell my front end where is the backend. And if this is not a static IP address, I can't define a static backend. So now what we are doing, we have a pods IP, but we would define this service IP in the backend definition, and this will have a pod IP address. This service to pod is from label to selector. Combination will happen, and this will find out which particular pod I need to send the packet. And from here also, whenever packet goes out, it will go to the service IP address, and from there the packet goes from here to here. And this latching between these two is on label and selector. So this becomes a block for us now. Pod plus service becomes one entity for us. Okay, so I would not just run pod without a service, so that if the pod dies, my IP address is not static. So always pod is never run alone. Pod will have a associated service with it. But service is giving us a data plane entry. If you see, it's not the control plane path, right? Application talking to application. This plane is data part, right? The data plane part. So the data plane communication is via this service. So whenever pod gets created, a service IP address we have to create separately. And whenever this gets created, Q-proxy is the one which goes ahead and writes rule on the IP table level, so that whenever the packets are coming, it transmits the packet to the correct set of pods. So you can think service is like a abstraction which is defining a logical group of a set of pods. Why it is saying logical group for a set of pods? Just imagine that I have two replicas of this running. When I say replica, what does that mean? If I'm serving uber.com in this container, I'm serving the same uber.com in this container as well. Then they are called as replica pods. So service has the intelligence that whenever I have replica pods, it understands that I have two pods at the back end of the service. So service is actually maintaining something called as endpoint list. And in this endpoint list, it keeps populating the pod's IP address. So it will have pod IP address, but these are replica pods. When a traffic is coming for uber.com, it will load balance the traffic across these two pods. So service is providing a logical grouping for a group of pods which do the same set of tasks, right? It is the same application running. And how does the service identify this pod? Using label and selector. Same way it will identify this pod also using label and selector. Because when we have this pod.yaml file, if you have seen, if I get 10 pods of the same type, it will get the same specification, same image, same label, everything would be the same, right? So we would talk about replicas when we deal with the controller section. At this point in time, we are not creating replicas because in kind pod, there is no placeholder to define a replica. So we are in this situation at this point in time. Later, we would see that when we are creating multiple replicas, service has the intelligence of load balancing as well across the replica pods. Now, let's go back to our slides once again. So, service is giving it a static IP address. It gives us an exposure for the application pods to other application or to outside the cluster as well. And when we have the replica pods, it load balances and even does a health check for the pod's health. Whichever is healthy, it will send packet to that. So you have a pod, you have a container inside it, you got a label with it, and container is listening on a port, pod has an IP address. Now I'm saying I'm giving you a static IP, and that is called the service. And service is one service, one type of pods. If I have 10 replica pods, all together will come in the same service, okay? But if I have a DB pod, I have an Nginx pod, I have a Redis pod, they will have their own associated services. One service can't send traffic to other type of application. It has only intelligence to select a specific label. Redis pod and Nginx pod can never have the same label, right? So Redis pod will have its own Redis service. Nginx pod will have its own Nginx service. So this is my Nginx service. This is my static IP address for that. So let's see if the pod goes off and it comes back, it will retain the same label. And with that label, service identifies what is the pod's new IP address and it can send the packet. Now let's understand there are different types of services depending on whether I want to expose my application within the cluster or outside the cluster. I can classify my service into different categories. If I want my application only to be accessed within the cluster, then I create a service type called as ClusterIP. And in that, my pod is only exposed within the cluster. It gets a IP address which would be in the ClusterIP range. It can talk to applications only within the cluster. It doesn't have any external connectivity. So if you see, you have a pod, you have a container in that, pod has an IP address. You're creating a service and that gets an IP address within the ClusterIP range. I have another pod called as pod B and I have a service B for it, which has an IP address which is accessible only within the cluster. So they both have a cluster IP type of service. Now when the packet goes, it will go like this. It will go from the pod IP to the service and to service B's pod B service to the pod B's IP address. So Nginx is talking to its Redis backend in this way. So cluster IP is the type with which you can expose your application within the cluster. If you see, my Nginx is in worker node 1, my Redis is in worker node 2, still then they can communicate because this IP address are resolvable within the cluster. It is in a range in which the complete cluster nodes can understand. They can resolve where exactly it is running. So this is cluster IP type of service. We have another type of service because for some application you would wish to expose that application outside the cluster. So in that case you would be creating a service type called as Nodeport. If you remember, we had host port type of network, host port network in case of Docker. What we did, we had a container and I wanted to communicate outside the node. At that point in time, I tagged to a port number on the host. Same way we would be doing that. We would expose the pod outside the cluster. Pod will get a IP address range of the cluster IP range. The service which we say as kind type Nodeport, that will also get a IP address of cluster IP range. But when I want to expose it outside the cluster, I want to provide external connectivity. What we do, we say type as Nodeport. As soon as you say type at Nodeport, on that particular node, it will get a port number. So in case of Docker, we used to specify the host port : container port, but we saw that when we are doing that, if that port number is already in use, our container never used to start. And here a lot of things would be done in an automated fashion. If you are the one who has to specify the port number, then a lot of the times the automation may not work if the port number is already being used. So we are leaving that responsibility to Kubernetes to assign us a port number on the node, which is a empty port, a port which is free. So if I want to expose my application outside, I'll create a service of type Nodeport. As soon as I define the service as type Nodeport, it will give me a port number on the node. And this is the port number on the node, 32050. And if I have to go outside the cluster or come inside the cluster, Nodeport to service to pods IP and then go to the container. That is how the traffic will flow. So I can reach my application from outside the cluster using node's IP address with combination to the port number. So this way I can expose my application outside the cluster as well. So now think that you have two nodes and you want to run a pod which has an IP address and a container running at it. So you will create a service for it. Service is not something which is created like a process, right? It's like an entry. So when you create a service entry, that entry is updated in every node in the cluster. And suppose you want a Nodeport type of service, then every node in the cluster gets that particular port number blocked for this particular pod. 32050, the last example which we took, that particular port number would get booked on every node in the cluster, so that if someone tries to access with node 1's IP address, till then the pod is reachable. If someone tries to access with node 2's IP address with 32050 port numbers, till then my application should be accessible. And in future, if I want to scale my pod to a different node, if I say replicas is equal to 2 in my controller, it will go ahead and create, and it will look for high availability. So it will never create 2 replicas on the same node. Rather, the second replica would get created on the second node in the cluster. And that point in time, this 32050 has to be free. And that is the reason we keep that particular port number booked in every node in the cluster, because in the beginning you never know that you're going to scale, and you may get placed due to scaling or due to recreation. At any point in time you may get created on any different node as well. So whenever a port number is booked, it is booked across the node in across the cluster in all the nodes. And service here takes the responsibility of load balancing across both the pod replicas. It will maintain the IP address of both the pods, and it will start to do load balancing. So these are 2 different types of services which we can create, and we would see how we do that in the lab exercise as well. So let's quickly move on to our hands-on and see how do we do this. We can have another type of service which is called as kind or type load balancer. In cloud, if you give the type as load balancer, it makes sure that your application gets exposed outside the cluster, and you have a load balancer created in the cloud provider's account. So here, if you have multiple nodes, and you are willing to run pods which are exposed via a service giving the static IP address, and I say my service is type load balancer, I get a cluster IP address for my service, no doubt, because load balancer will give me external connectivity. But still, if any internal communication happens, that happens on the private IP address. Because load balancer would be having connectivity on the nodes, so we should have a port number as well allocated for it. So node port is also present, and then finally I get a external load balancer. This external load balancer would reach the node port IP address, and we would be going from cluster IP to node IP to the load balancer. And if I want to reach from outside, my packet comes to either of the nodes. So my load balancer's backend is the multiple worker nodes on that port number 32050. If packet arrives on 32050, it's equivalent to Nodeport type of service. Only you are not giving node's IP address and a port number to your customer or client or team. Rather, you would be giving a single IP address, which would be the load balancer's IP address. And Nodeport's packet would arrive to the service, and from there it can be distributed to either of the pods. The load balancing can be done. And in case my load balancer is sending to any other node, because of the load balancing which is configured in the load balancer itself, my packet gets routed to the pod wherever inside the cluster it is existing. Difference here that you get the node port, you get the cluster IP, but you have an external load balancer created, which helps us in providing a DNS name or a single IP address, a single point of contact for my team or the client. In case of Nodeport, I had to individually give this IP address and the port number, but here I would give a single IP address. If one of the nodes is not down as well, that's the responsibility of this load balancer, that it does the health check of the backend systems and it removes the unhealthy backend. So load balancer will route our request to the healthy backend, which would be the healthy node in the cluster. And whenever packet reaches at 32050, it will get routed for this pod. If I have another pod, which has to be exposed with type load balancer type of service, I'll have another load balancer created and I'll get a different node port number, right? Suppose I have app 2 and it has got assigned 32051. So the other load balancer's responsibility is to forward the packet on the nodes in the cluster on 32051 port number. And whenever packet arrives on 32051, with the IP table rules and the service entry and all, we get to know which particular pod the packet has to be forwarded to. So here, what we are discussing, we have seen different types of services. First one was the ClusterIP, second one was Nodeport, third one was the load balancer. So if you say ClusterIP, this is like getting a private IP address. If you say Nodeport, you get a private IP address, but you get an external connectivity using node's IP address and a port number. And when you say load balancer type, you get both of them. And you get an external load balancer too. And external load balancer's work is to transmit the packet to the node port. From there, it goes to the cluster IP address. And from there, it finds out the pod's IP address. But I mentioned that as many applications I want to expose to the outside world, obviously this is not the preferred one. I would be creating a load balancer. And when I create several load balancers, it's very difficult to manage them. If I have 10 applications which have to be exposed outside the cluster, need external connectivity, I will have 10 load balancers. So solution to this is, these load balancers are layer 4 or network layer load balancer. If a packet comes, it can't open and check what exactly is being sent in the packet and where the packet has to get routed. But if we have layer 7 load balancers, which are also called as Ingress controllers, this controller, the word controller, don't get confused with it. It's not like a daemon set controller or a stateful set controller or deployment controller. This Ingress controller is just an application which has the capability of balancing the load or sending the traffic to the correct destination or the backend by looking into the content of the packet. So here, if you see, all the traffic of mydomain.com/bar, any other traffic, my domain, foo.mydomain.com, all traffic comes to the single IP address. This would be a layer 7 load balancer. Packet will come to all different types of packets are coming to the same endpoint. And this guy has an intelligence to understand, okay, if it has come from mydomain.com, I need to send to service 2. If it has come from foo.mydomain.com, I need to send it to service 1. If it has come from other, then I need to send it to service 3. That intelligence, when we get, that is called as an Ingress controller setup. So you will have a cluster, you will implement a lot of services. For each one of them, you would be setting up load balancer. That becomes a tedious job. A lot of effort is needed and cost associated as well, because these load balancers are cloud load balancers in a cloud account. So instead of doing that, instead of having a load balancer for each of the service, what we can do, we can create multiple services, and these services will have just the cluster IP and the Nodeport cluster IP type of service, nothing else. And I'll create another application and a service. This is my application, which is an application layer load balancer application. How we have an Nginx web server, how we have a Redis application, this guy is meant just to do load balancing by opening the packet. So this is also running as any other application in the cluster. So if I have a pod and I want to expose it outside the world, I create a service, and that service type would be load balancer. Then the load balancer gets created. Now I'll have a single load balancer created, but still I'll be able to load balance the traffic coming for service B and service C both. How? When the packet comes to the Ingress pod, this Ingress controller pod, it has a set of rules associated to it. It goes and checks the rule. What sort of rule? It has that if you're trying to open xyz.com, then route the traffic to service C. If you're opening web page of abc.com, route the traffic to service B. Like those entries are maintained, which are called as rules, and it's called as past-based routing. So you are routing depending on what you have given. You can even write abc.com/demo and have a different service altogether. I can say abc.com/Christmas sale. I can have an entirely different service which is showing a website for Christmas sale season. So this way, I'm decreasing my workload, right? I just have one single load balancer, and this is network layer load balancer or layer 4 load balancer. It can send traffic to the service of Ingress type of application, and this application has a kind Ingress associated with it where you can define your rules with respect to the services which you want to get routed for. And looking at this rule book, the routing of the packet does happen in the cluster. So any traffic which is coming, for which we have written the rules over here, like xyz.com, abc.com, all traffic will come directly to this pod, and from this pod it will go outside. So what exactly we are understanding? That Ingress Controller is an intelligent load balancer. It is a layer 7 load balancer. Some examples are Nginx or Nginx Plus. They don't run as part of the Kube Controller Manager. And with Ingress, you don't directly reach your application services. If I want to expose my application, I expose it on the ClusterIP level itself. All the external traffic comes to my Ingress controller application, and from there it gets forwarded to the respective services.
So guys, this was our expert from Team K21 Academy, and if in case you missed upon any concepts or if you want to dive deeper, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get you higher paying jobs, and in this interactive session we will be learning about why learn containers, that is Docker and Kubernetes. You'll be learning about the whole Docker container architecture. You'll be getting to know about some hands-on demo. You'll be getting to know the certifications regarding Kubernetes, CKA, CKS, and CKAD. And we do have Q&As along with a limited time gift. So if you want to enroll for this free class, all you have to do is just log on to k21academy.com/K8s02. And after that, you just have to click on book your free seat now. And after that, you just have to select an event date according to your availability, add your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of URL. You can add this URL to your calendars, and I'll see you in the free class. Till then, take care and keep learning.